We are going to learn how to find the area of regular polygons. And as a reminder, we've talked about regular polygons before, but a regular polygon means all the sides are congruent and all the angles are congruent. That is what a regular polygon is. So there are a couple things that we need to talk about with regular polygons, some vocabulary that we need to get out of the way at the beginning. The first one is this new word called the apothem. In a regular polygon, an apothem is a segment that goes from the center to the side and is perpendicular to the side. If you look at this picture that's printed down here with the circle and then the five-sided figure, the pentagon, the circle has been circumscribed around this pentagon. And if you'll notice, this segment right here has a line pointing to it. This is the apothem. It goes from the center to the side of the polygon, not to the edge of the circle. It goes from the center to the edge of the polygon, to the side of the polygon, and it makes a right angle where it hits the side of that polygon. Then we have radius. Seems a little bit weird to talk about radii if we're talking about polygons, but when you look at this picture, it makes a little bit more sense. A radius is a segment that goes from the center to a vertex. A radius goes from the center to the edge of the circle. In this picture here, the circle has been drawn around the outside of the pentagon. It is circumscribing the pentagon. And we have this segment that goes from the center to the vertex of the pentagon, and the vertex of the pentagon is on the edge of the circle. So this segment right here is a radius. It is a radius of the pentagon. And then we have perimeter. Perimeter is the sum, so that means you add, of all the side lengths of a polygon. Thank you. We just started our notes on page 4. The sum of all the side lengths of a polygon is the perimeter. Now, we've calculated the perimeter for some different shapes already this semester. When we've had shapes with different sized sides or with a small number of sides, we just take all the sides and we add them together. When I have a regular polygon with a lot of sides, because we can have 6 sides, we can have 8 sides, we can have 10 sides, we can have 12 sides, that gets to be a lot of things to add together. And so we have a shortcut for regular polygons. Since in a regular polygon, all the sides are congruent, to find the perimeter, we can take the number of sides and multiply it by the length of one side. Number of sides times the length of one side. It's just a shortcut for me to add up all of those sides since they're all the same size, and the number that I have of those will be the same as the number of sides. All right. Now we're going to get into some area formulas. We have 2 different area formulas for a regular polygon, and we're going to choose which one to use based on the information that we've been given in the problem. When we've been given the apothem, then the formula that we use is A equals 1/2, capital A equals 1/2, lowercase a times capital P. The capital A stands for area. The lowercase a here stands for apothem. And the uppercase P stands for perimeter. So area equals 1/2 times the apothem times the perimeter. If we have been given the radius, then we use a different formula. When we've been given the radius, then we have capital A equals parentheses 1/2 AB times the sine of angle C times lowercase n. Once again, this capital A stands for area. Way over on the right, the lowercase n stands for the number of sides. And hopefully you guys recognize this 1/2 AB sine C as an area formula for a triangle. This is the central angle triangle. So if you look back at this picture with me, if we were to draw in 2 radii here, I'm going to draw in a radius from P to E and from P to D. That makes this triangle right here. We find the area of the triangle using 1/2 AB times the sine of angle C, then multiply by the number of sides. The reason that we're doing that, 1/2 AB sine C finds the area of this little triangle right here. If I draw in all of the possible radii in the circle, I have 1, 2, 3, 4, 5 little triangles, which is the same as my number of sides. That's why we're multiplying by the number of sides, because that's how many congruent triangles I can chop this shape into. We are going to do a little bit of review from chapter 10 because that comes into play in this before we actually find the area of polygons. So I'll leave it up here for just another moment or so before we go on and look down at example number 1. Let's go look at example 1 now. Polygon ABCDEFGH is inscribed inside circle O. Write down a specific segment, angle, or arc for the following and find its measure if possible. So in this drawing, I see 2 radii that have been drawn in. Can you guys name one of the radii? Close. That goes to the side. We have to go all the way to the circle. BO. Is there another one? And AO. The one that you named first, JO, that one goes to the side. So what would we call that? An apothegm. So JO is the apothegm. BO and AO are both radii. All right. C, minor arc. A minor arc is any arc that is less than 180 degrees, but the one that jumps out at me based on the way they've drawn this picture is this one right here. It's in between those 2 radii. So that's the arc that I would name for my minor arc, arc BA. And we want to find the size of that minor arc. In order to find the size of the minor arc, I would need to know the size of the central angle. And to find the measure for the central angle, we do 360 divided by the number of sides. So on this one, we would do 360 divided by what? How many sides does this shape have? 8. And what is 360 divided by 8? 45. So the measure of the minor arc is 45 degrees. How do we know it's an arc? Because it's part of the edge of the circle. So this angle right here is 45 degrees. That's a central angle because its vertex is at the center. And so the arc that is being intercepted by that central angle has the same measurement. That's stuff that we talked about in Module 10. All right, a major arc. A major arc has to be more than 360 degrees. Well, if I did BA as my minor arc, I could go the other way around the circle from B to A this way, and that would be more than 180 degrees, more than half the circle. But if I'm going to go from B around the long way to A, I have to name this arc with 3 letters. So I have to start with B, and then I need one of these letters over here to tell me that I'm going from B the long way around the circle. So we could do B, D, A. We could do B, E, A. We could do B, F, A. I just need that middle letter to show me that I'm going not straight from B to A, but the other way around. So I'm going to do B, E, A. But again, you could do B, D, A. You could do B, F, A. You could do B, G, A. And we want that measurement as well. How many degrees is it around a whole circle? 360. And this is almost the whole circle, except for how much? 45. Except for 45 degrees. So I can do 360 degrees minus 45 degrees. What is 360 minus 45? 315. Great. Part E, central angle. Well, we already marked a central angle up here, and we already found its size. We had to do that to find the measure of that arc. So we have angle BOA, and it is 45 degrees. And now this last one, part F, an inscribed angle. An inscribed angle has to have its vertex on the circle. So I could look at, say, for example, this angle right here, angle OBA, because it has its vertex on the circle. And we want to find the size of that angle. Well, to find the size of that angle, I'm going to focus on this right here, what I just highlighted in pink. I highlighted a little triangle. And what's this marking right here? It's a right angle. So the whole reason that I'm looking at just this little piece is because that's a right triangle. And I know that a right angle is how many degrees? 90 degrees. If I can figure out how big this angle is right here, I know the 3 angles in a triangle add up to 180. So then I could add those 2 smaller angles together and minus it from 180 to find this angle here, OBA. This apothem is cutting this angle, BOA, in half. So this angle over here, right here, is half of 45 degrees. So I would take 45 degrees, cut it in half, divide it by 2. What is half of 45? 22.5. Yes. So we have the measure of angle OBA plus 90 degrees plus 22.5 degrees equals 180. Those are the 3 angles inside this little pink triangle. We're going to combine our like terms together here, the 90 and the 22.5. What is 90 plus 22.5? 112.5. That's going to be equal to 180. And then I would subtract 112.5 from both sides. What do we get when we do 180 minus 112.5? You said 67.5? Yes, the measurement of angle OBA is 67.5 degrees. Nicely done. All right. Let's spend our last 14 minutes finding the perimeter and the area of some regular polygons. Let's look down at number 2 next. Number 2 has two pieces, a part A and a part B. We're supposed to find the perimeter and the area of each regular polygon. Well, the perimeter we wrote down a formula for that. We said the perimeter is equal to the number of sides times the length of each side. How many sides do we have in this picture? 5 sides. Right here it shows me that from this corner down to this corner is 18 feet. So that is the length of one side. And because it is a regular polygon, that means all 5 sides are congruent. So we do 5 times 18. What is 5 times 18? 90. So the perimeter is 90. Should we put units with that? Feet. Yes. 90 feet for the perimeter. And then we're also supposed to find the area. What is this segment right here? Is that an apothem or a radius? That's an apothem. Goes from the center to the edge, makes a right angle where it hits that side. When we've been given the apothem, the area formula that we need to use is area equals 1/2 apothem times perimeter. So the area equals 1/2 times my apothem of 12.4 times my perimeter of 90. And now I need to grab my calculator and type all that in. 1/2 times 12.4 times 90. 558. Should we put units with that? Feet squared, yes. It's feet squared because we just found the area. Anytime we are finding the area, it is units squared. So 558 feet squared. Nicely done. Let's try another one that's similar to that. Over on part B, we're going to find the perimeter first. The perimeter is equal to the number of sides times the length of each side. How many sides do we have? 6 sides this time. How big is each side? Nope. Each side is 30. Right here it shows me this side is 30 meters. So we do 6 times 30. What is 6 times 30? 180. What kind of units should we put with that? Meters. 180 meters. And then this segment right here, what is that? That's an apothem, yes. Goes from the center to the side, makes a right angle where it hits the side. So because they gave us the apothem, we're going to use area equals 1/2 times the apothem times the perimeter. So area equals 1/2 times 26 times the perimeter of 180. What does that one come out to be? 2,340. What kind of units should we put with that? Meters squared. Absolutely. Awesome. We're going to go and look at number 3 on the next page. I don't know for certain that we'll get all the way through it, but we're going to get as far through it as we can. On number 3, they've only given us one piece here. They've just given us this. Is that an apothegm?
No, that's a radius.
That's a radius. We had a different formula to find the area when we were given the radius. What was that area formula? Yes. 1/2 AB times the sine of angle C times the number of sides that we have. So if you guys remember, back on page 4, I showed you that we're going to make a little triangle down here. So the very first thing I'm going to do is draw in another radius so that I create a triangle down here. That 1/2 AB sine C is going to find the area of this triangle. And then we're going to multiply it by the number of sides that we have, because that's how many triangles I could split this shape into. What do you know about the radii of a circle? It's half the diameter. If I draw in 2 radii in the circle, will they be different sizes?
No.
No. They're congruent. What do you think is true about these 2 radii? They are also congruent. So if the one radius is 4, this other radius over here is also 4. Then we need our central angle. The measurement of the central angle is equal to 360 divided by the number of sides. So 360 divided by what? Divided by 5. What is 360 divided by 5? 72. So this angle up here, right here, is 72 degrees. A and B are both sides, so in the place for A and B, we're going to put 4 for both of those. So I have this 1/2 out in front here, times 4 times the sine of my angle, 72 degrees, times the number of sides. How many sides do we have? 5. All right, I can pop it into my calculator just like this, but that's a lot of numbers to enter into my calculator, and so that's a lot of places where I could make a mistake as I'm typing things in. Why don't we clean up this front part right here? This 1/2 times 4 times 4. What is half of 4? 2. What is 2 times 4? 8. So this would be the same thing as 8 times the sine of 72 degrees times 5. Again, you can type it in with the 1/2 times 4 times 4 times sine of 72 times 5. Or we can simplify that front piece, so what we're typing into the calculator is 8 times sine of 72 degrees times 5. What do you get when you put this one in the calculator? 38 point, and then I didn't hear the decimal part. 0.42. Should we put units with that? We don't have any units to use. To keep yourself in the habit, it would be a good idea when you haven't been given units to write down units squared. But if you leave that off because you were not given any units, that is perfectly fine, and I will not take off any points. All right, so that's finding the area. We still need the perimeter, though. To find the perimeter, I need to know the length of this side right down here. So I'm going to redraw this little triangle over here. So there's my triangle. I know that these two sides are the same size. They're both 4. And then I'm going to draw a segment that goes from the vertex straight down to the bottom. And it makes a right angle when it gets there. Technically, that's an apothegm because it's going from the center to the side, and it makes a right angle where it hits the side. The whole reason that I'm doing that is because I want to look at this triangle right here, and I want a right triangle so that I can use special things that can only be used with right triangles. So that's why I've taken this triangle and cut it in half. The angle up at the top, up here, do you guys remember how big this angle was? 72 degrees. Well, that red line that I drew in is going to cut that in half. So I need half of 72 degrees. What is half of 72? 36. So this angle right here is 36 degrees. I need to find this right here because it will be the same size as this right here. And if I can find this, and this is the same size, then I can find the side of this polygon. We're going to use right triangle trigonometry. Do you guys remember SOHCAHTOA?
Yes.
So using SOHCAHTOA, I'm going to stand up at this angle up here. And I'm going to label my sides. The side that I'm looking for down here, would that be opposite, adjacent, or hypotenuse? Look at where I'm standing. This is the opposite side. Because from where I'm standing, I have to go through the center of the triangle to get over there. It's not touching the angle that I'm standing at. What is this for then? That's my hypotenuse. It's opposite the right angle. All right, let's go ahead and set this up, and then we will save actually solving it until tomorrow. So if I have opposite and hypotenuse, do I want sine, cosine, or tangent? I want sine. So I have sine of 36 degrees equals opposite. Do we know how big the opposite side is? Nope. Opposite side over my hypotenuse of 4. And that's what we will solve tomorrow. Have a fantastic rest of your day, guys. Homework that you picked up on your way in the door is not due until next Wednesday. We have a week to work on that homework. Homework is due next Wednesday. Bye. Have a good one.